Welcome to this next step in your programming journey, that is transitioning to Python. After exploring the principles of OOP in C++, we will now shift gears to a new but a related world, that is Python. So in this session, we will see how Python makes programming faster, cleaner, and more expressive while keeping all the logical power you have already built up with C++. So let's get started. Here's what we will cover in this transition session. We will start by installing and setting up Python on your system. Then we will move into fundamentals that are variables, data types, Python's flexible nature when it comes to mutability. From there we will explore control structures and input-output. Next we will visit functions including arguments and recursion to see how Python simplifies many things that you have already done before in C++. Finally, we will introduce the basics of regular expressions, that is a powerful tool for working with text. So let's begin by fetching the latest and greatest standard Python release from the official website, that is python.org. Python uses an interpreter, which is a special program designed to execute other programs. When you write Python code, the interpreter reads your instructions and carries them out immediately. So think of it as a smart middle layer between your code and your computer's hardware. Unlike languages such as C++ or Java, Python doesn't require a pre-compilation or linking step before execution. You simply type your code and run it. In Python, everything happens at runtime. There is no initial compile time phase. Even the creation of functions or classes and import of modules occurs dynamically as your program runs. However, Python does perform one translation step behind the scenes. It first compiles your source code into a form known as bytecode. So bytecode is a lower level platform independent representation of your code that allows Python to execute your program faster. So in short, when you run Python program, your source code is first translated into bytecode, and then the Python virtual machine, that is PVM, executes that bytecode efficiently. Before we dive deeper into Python coding, let's take a step back and understand how Python fits into the broader world of programming languages. The primary difference between the scripting language and a programming language lies in how their code is executed. A traditional programming language such as C or C++ uses a compiler. It translates the entire source code into the machine code before the program can run. Once compiled, the program executes directly on the hardware. A scripting language, on the other hand, uses an interpreter. So interpreter translates and executes the code line by line without a separate compilation step. So while the compiler processes your code all at once, an interpreter works step by step as the program runs. So technically, Python is a high-level interpreted programming language, but in practice, we often use it as a scripting language when we write simple programs or maybe automation scripts that are executed directly. A Python file that is meant to be run directly by the user is commonly known as a script. In contrast, a file that defines reusable functions, classes, or variables designed to be imported by another file is known as a module. So in short, scripts are made to be executed and modules are made to be imported. Most real-world programs combine both. A main script that imports several modules, for example, maybe a game project might have a main file called game.py that runs the game and a separate file raw.py that defines the drawing logic. So this structure helps keep the code organized and reusable. Now that Python is installed and ready to use, let's talk about where you will actually write your code. You can always use a built-in IDE that comes with the Python or even a simple text editor like a notepad. But for serious development, a dedicated environment is much more efficient. So two popular options are PyCharm and Anaconda. So PyCharm, developed by JetBrains, is a powerful IDE built specifically for Python. So it provides features like intelligent code completion, syntax highlighting, debugging tools, version control integration, and project management all in one place. If you are coming from C++ in an IDE like Visual Studio, so PyCharm will feel familiar. It is designed to streamline larger software projects. On the other hand, Anaconda is not just an IDE, it has a complete Python distribution. It comes pre-packed with the most commonly used Python libraries for AI, data science, and machine learning, including NumPy, Pandas, Matplotlib library. So Anaconda also includes its own environment manager called Conda and an IDE called Spider, which is great for data analysis and scientific computing. Here's a simple rule of thumb: if you are focused on software development or building large applications, use PyCharm. If you are working on data science, AI, or research, then Anaconda is your best choice. Whichever you use, both of them make Python code easier, faster, and much more organized. In Python, everything is an object: numbers, strings, list, or even functions. Each object in Python carries three important pieces of information: the reference count, type, and value. The reference count defines how many names or containers are pointing to this object. The type defines what kind of object is it, such as is it int, float, or list. Value represents the actual data stored inside that object. Now here's a key difference from the languages like C or C++. In a C++, a variable like, for example, x directly owns a specific memory location. The data 2337, for example, is stored right in that slot. But in Python, things work slightly differently. When you write x is equals to 2337, the Python interpreter creates an integer object that owns the memory for the value 2337. The name x doesn't own that memory, it simply points to the object. So instead of x owning the block of memory where 2337 resides, the object itself owns the memory. The name x is just a reference, a label to that object. The interpreter tracks how many names point to that object using a reference count. When no names or structures refer to it anymore, then the Python's garbage collector frees that memory automatically. So reference count increases when another name points to the same object. One of the first things you will notice when moving from C++ to Python is that you do not need to declare variables before using them. In C++, you must define the type before assigning a value. For example, int x is equals to 10 or float y is equals to 5.5. But in Python, a variable is created automatically when you assign a value. You simply write x is equals to 10 or y is equals to 5.5. Python figures out the data type based on the value you assign, and this is called dynamic typing. Once the variables are created, you can easily display them using the print function, for example print x, and these functions as shown on the screen. So the print function sends output to the screen. It can show text, numbers, or even expressions all at once. This makes Python a very beginner friendly since you can write and run your code without worrying about type declarations or maybe compilation steps. Notice that we didn't use int, float, or string anywhere. Python automatically detects the type, and we didn't need to include semicolons or even any header file, just assign and print. In Python, user input is handled by input function. The syntax is simple, so you write variable is equals to input function. When Python executes this line, it displays the prompt text and waits for the user to type something. Whatever the user enters is always read as a string, even if it looks like a number. For example, if we pass enter your name string as an input, notice that if we try to do a calculation like age plus 5, we will get an error because age is still a string. To fix this, we need to convert it into integer or float using int and float functions. For example, like age is equals to int of and then of input, so on. Split function helps in getting a multiple inputs from user. It breaks the given input by a specified separator. If a separator is not provided, then any white space is a separator. Generally, user uses a split method to split a Python string, but one can use it in taking multiple inputs. So syntax says that you write input, then dot split, and you pass a separator to a split function. Programs often need to make decisions to do one thing if a condition is true and something else if it's false. So in Python, decision making is done using control structures like if, elif, and else.